Okay, today we're on 7.2. Okay, 7.2. What we're going to be working on today is we are going to add and subtract. Add and subtract rational expressions. Okay, does anyone remember what is a rational expression? What do we say a rational something is? A fraction. So we're going to be adding together fractions, adding and subtracting fractions. Sometimes they will have a common denominator already, sometimes they will not. Okay, so it just depends on the problem. For your first one, x plus 6 over 3x minus x minus 5 over x squared. X plus 6 over 3x minus x minus 5 over x squared. Now, in Algebra 1, depending upon who you had as a teacher, some teachers taught you basically the easy way or the simple way for some people to get a common denominator. And the way you would do that is you would take, if they have different denominators, you would just multiply the other fraction by the other denominator. Okay? That's a simple way that you'll always get the correct common denominator, but it makes really big fractions and you end up having to reduce later. So I do not want you to do it that way, okay? Because it makes your life a little more complicated in the end. So what we're going to do is I'm going to show you how to first, I want you to find the LCM. Does anyone know what LCM stands for? Least common multiple, right? Okay. The way that you find the LCM is we take each denominator and break it down. So how can I break down or factor 3x? What is 3x made up of? 3 times x. Okay. Then I want you to do the same thing. I'll zoom out for you. I want you to do the same thing for the other denominator, x squared. Okay, what is x squared made up of? X and x. Okay, the way that you find your LCM is you want to figure out which parts you have to have. You have to have every single part there. So we know we have to have a 3. Okay, so I've used my 3. I also know I have to have an x. Okay, so I've used an x. That means I already have in my LCM one of these x's, right? So what else do I need to get my LCM? One more x. Okay, so I have to have every single part. So what my LCM is, or what my common denominator will be, is actually 3x squared. Okay, that is what your common denominator is going to be. So if I need to get to 3x squared, what would I have to multiply by? What am I missing in my first fraction? An x. Okay, so you would multiply by x in the numerator and x in the denominator. Then what am I missing in my second fraction? A 3. So you're going to multiply by 3 over 3. You can't just multiply on the bottom, okay, or just on the top. We have to multiply by the top and the bottom. Okay, so if I actually multiply this out, I want you to distribute in the numerator. That would give you x squared plus 6x over, we have a common denominator of 3x squared. Subtract is still in between. And then distribute. X times 3 gives you 3x. Negative 5 times 3 gives you minus 15 over 3x squared. Now that I have the same denominator, I want you to write everything all over one fraction. So x squared plus 6x. Now, what is this negative? What does it belong to? Does it just go to the 3?
No.
No. This has to be distributed to both. Okay, so when you write it all over one fraction, make sure you distribute if you have any negatives there. So minus 3x and negative negative gives you plus 15. All over 3x squared. Combine like terms if you can. So this one would be x squared. The positive 6 and negative 3x gives you plus 3x plus 15 over 3x squared. And then we're right back to where we started yesterday. Okay, you have to factor and reduce if you can. Can this be factored? Can anything multiply to 15 and add to 3? No. So you're done. Okay, so that is our final answer for this problem. So if you can factor, you should, because a lot of times you can reduce with the denominator. If you cannot factor, then that is your final answer. Now, can I reduce the x squareds here?
No.
Or the 3's? No. Okay, anything that is attached to something else by a plus or minus cannot be reduced at all. Okay, let's try another one. For number 2, I want you to, how about 3x minus 4y over x plus y plus 2x plus 9y over x plus y. 3x minus 4y plus 2x plus 9y over x plus y. So this one already has a common denominator. So all that means is you are not going to have to multiply by anything to get a common denominator, since you already have one. Since you have a common denominator, what we're going to do is we're going to combine everything all over one big fraction. Okay, so if I rewrote this, combine everything all in one big fraction. So 3x minus 4y plus 2x plus 9y. And there was nothing to distribute, so nothing changes. All over x plus y. Then combine like terms. So 3x plus 2x gives you 5x. Negative 4y, positive 9y gives you plus 5y over x plus y. Now what do you think I can do? Reduce. But before I can reduce, what do I have to do? Factor. Okay, take out a GCF. You could take out a 5 in the numerator. So 5 times x plus y over x plus y. So here the x plus y's are going to do what? They'll reduce each other away. So you end up with just 5 as an answer. And that's it.
So your answer is just 5.
Answer is just 5. That's it. So if we can reduce, then you have to. Question so far? Okay, let's try another one. Number 3, I would like you to combine 7 over x squared plus 2x plus 4 over xy plus 2y. 7 over x squared plus 2x plus 4 over xy plus 2y. Do these have a common denominator right now? No. So we have to find the LCM to figure out what is going to be their common denominator. So the x squared plus 2x, how can I break that down? Can that be factored? Yes, x times x plus 2. Okay, we can break that down. And then the other fraction, xy plus 2y, is its denominator. How can that be broken down? Factor out a y, and you'd be left with x plus 2. So to find your LCM, okay, to figure out what is our common denominator, what do I need from the beginning? You know you need an x, and you need the x plus 2. Okay, so I've used my x and my x plus 2. Here, I've already used this x plus 2, so what else do I need?
Y.
Just a y. That is what I want my common denominator to be. Now, you're not actually going to multiply it out yet. I want you to leave it in factored form, because if we can, just like up here, we'll reduce. So what's missing? So actually, it's a little bit easier if we rewrite this in factored form. So this is x times x plus 2. It's a little bit easier to see what's missing. And that would be, oops, sorry, y times x plus 2. Okay, so now it's a little bit easier to see what do I have to multiply my first fraction by?
Y.
A y, because that's what's missing. What do I multiply the second fraction by? The x, because that's what's missing in it. Now, if you multiply 7 times y, it gives you 7y over x times y times x plus 2. Now, I want to reorder that just because it makes more sense to put single variables at the beginning. Okay, plus 4x, because I multiplied, over x times y times x plus 2. And then finally, go and combine these along the same line. So on the same numerator, 7y, plus 4x over x times y times x plus 2. And can I factor anything there? No. Can anything reduce? No. That is your answer then. Yes?
When you do the y, why doesn't it distribute into the parentheses?
This y up here? Because I want your answers to be in factored form. I don't want anything to distribute in, because if you can reduce something, it has to be factored first. So there's no point in actually multiplying it all out in the bottom, because then you just have to factor it again. Okay, a couple more. For number 4, okay, number 4, I want you to add 7 over x squared plus 7x plus 10 plus 5 over, plus 8, where I got 5, plus 8 over x squared plus 5x plus 6. 7 over x squared plus 7x plus 10 plus 8 over x squared plus 5x plus 6. So to find your LCM, what are you going to have to do here? Factor first. Okay, so what is x squared plus 7x plus 10? What does that factor into? You can just do it right underneath. What multiplies to 10 adds to 7. So they can be both positive, both negative, or one of each. Both positive, so x plus 2 and x plus 5. For your second equation, how does this factor? We can have both positive, both negative, or one of each. Both positive. So what multiplies to 6 adds to 5?
3 and 2.
3 and 2. Okay, it is not 6 and 1. Okay, so now hopefully you can tell, what are we missing? Okay, if I had 7 over x plus 2 times x plus 5 plus 8 over x plus 2 times x plus 3. What is my LCM going to be? What is my denominator going to be? We know we have to have the x plus 2. We know we have to have the x plus 5. What else do I need?
3.
The x plus 3. Okay, so what is this first equation missing? The x plus 3. So we're going to multiply on both the top and the bottom. What is the second equation missing? The x plus 5. Okay, so if you distribute through here, that gives you 7x plus 21 over x plus 2 times x plus 5 times x plus 3 plus, distribute again, 8x plus 40 over x plus 2 times x plus 3 times x plus 5. Does it matter that these denominators are in a different order? No, it's fine. They're all being multiplied. Now, this is another reason we don't actually want to multiply things out in the bottom, because that would be a really big number. Okay, that's just more work than we need to do. Now that we have the same denominator, you can combine the numerators. So just combine like terms. So 7x plus 8x gives you 15x. 21 plus 40 gives you plus 61 over x plus 2 times x plus 3 times x plus 5. And then factor and reduce if you can. Can this be factored at all? No. No GCF? Can anything reduce? Nope. So you're done. That's your answer.